All right, so here we go. We're going to do domain and range from graph in this video. So we got to talk about domain, we got to talk about range, but before we even get into domain and into range, I do want to just quickly talk about the different types of graphs that you can find, one of which is called discrete. So let me go ahead and type that in. All right, here we have discrete graphs, and then we also have something called continuous graphs, right? So a discrete graph is when you have some sort of graph where, trying to think of the easiest way to say this, where the graph has a break in it. A continuous graph is any graph where there's no break in it, all right? So let's talk about continuous. Maybe that's a little easier to define. A continuous graph happens when you have some sort of line, curve, some sort of function being graphed where it starts somewhere, or it could come from off the screen, but it starts somewhere and it goes smoothly throughout however it goes and it stops, all right? That is a continuous function. A discrete function is one that has a break in it. A break in it means that as I start to draw the function, I at some point in time have to pick up my pen and go to another location and put it back down. So the one that we're looking at over here, this g function that's for the first problem, that is a discrete function because to get from this point to this point, I have to pick up my pen. It's not connected. Another type of discrete function would be something like this, and then all of a sudden it goes over here. There's a break in the graph. Many times when there's things like this, what you'll see is one of them will have an open circle and one of them will have the filled in circle. So discrete basically means there's a break somewhere in the graph. So as I go through these problems, you're going to hear me say the word discrete. That means it has a break. Continuous, that means that there is no break and it's a nice smooth line. And so we'll go from there. So this first problem says, what is the domain of G? Domain is our X values and range is our Y values. So the domain is the set of all the inputs, of all the X values. And so if you ever forget, like, well, which one's which, here's a good little thing to remember. You have X and you have Y, right? Like there's ordered pairs, X and Y. X comes first in the alphabet, right? Q, R, S, T, U, V, W, X, Y, right? X comes first. In domain and range, D for domain, R for range, which one comes first in the alphabet? Domain comes first in the alphabet, right? So since domain comes, the letter D comes first in the alphabet, then it would pair up, it would partner up with X, and R is later in the alphabet, so it's going to partner up with Y. So if you ever forget, dang, I can't remember, domain, is that X or is that Y? Is that our input or is that our outputs? Think about what comes first in the alphabet, domain, D or R? Okay, D's first in the alphabet. So D is first in the alphabet, X is first in the alphabet, they go together. Domain is our X values. So on this problem, we need to figure out what is the X values at this point, this point, this point, this point, and that point. And it's going to be the set of all those points. So in this case, because it's discrete, it's not going to necessarily be a subset that's a continuous subset like a compound inequality right here. It's going to be a variety of little points. So the value of X right here is 0, 2, 4, 5, 7. 0, 2, 4, 5, 7. That is the domain of that graph. Domain, again, domain, we're just saying, hey, what's the set of all of your input values? And it is 0, 2, 4, 5, and 7. Let's take a look at the next question. This is a continuous graph. Notice how if I put my pencil down here, I could trace it by going here, going up and over, and then going down. Continuous. What is the domain? So we're still talking about our input values. We're still talking about our X values. What is the domain of the function h? Now this time, it's not just this point and that point, or this point and any other point. It's all the points from -7 over to 7. It's nice and smooth. So these are all a whole bunch of points that are included. All these things are included. All these things are included in the domain. So it's not going to be something like this, because it's not just a set of finite points that are in the domain. When it's continuous, your domain is going to be a set of all points from one number to another, because everything in between is included. So it starts at -7 and it's all the x values from -7 to +7. So it's this one right here. -7 is less than or equal to x, which is less than or equal to 7. We're saying that our x values, our input values, are everything between -7 and 7. And the or equal to is because these things here are filled in, right? Those are filled in circles. If there was an open circle, then you wouldn't have the or equal to at the bottom. Let's see what the next one provides us. What is the range? Range, y-axis, range. So what is the y values? This is discrete. So it's just going to be a finite set of points, just individual points. It's -4, 2, 2, 4, 6. Talking about y values, right? -4, -2, 2, and 6. It's those values there. The h of x, which is the output values, -4, -2, 2, 4, and 6. Those are the outputs. Those are the range of that function. Now we have a continuous graph. What is the range? This is the one that honestly I think students struggle with the most because they naturally want to just go from this point to that point like we did with domain. Can't do that, all right? And here's the reason why. For the x values, we go as far from the left as possible, as far to the right as possible, and that works, that's fine. But in the y values or in the range, that's not the case. The y values go below here. So what you actually want to do is go to the very, very bottom of, there you go, right there, right? This is the very, very bottom of the function. Go to the very, very top. So your range is all values between those two lines that I just drew. It's all of them. It's all those values together. It's not just from this point over here. It actually goes down to -5 and all the way up to +5. So your range is all the values between -5 and +5 for your outputs, for your output values. So let's take a look. -5 is less than or equal to f of x, which is less than or equal to 5. F of x is a fancy way of saying output, all right? It's the output values. All right, here we go again. Domain. Domain is x values. It's a discrete graph, so it's just going to be some individual points. We got -2, 1, 1, 5, 6. -2, -1, 1, 5, and 6. And another one, it's continuous. So it's a continuous graph. In domain, talking about our input values. So how far to the left does it go? It goes all the way over to here. I think when I drew those little lines, it may have actually helped last time. It goes all the way over to -5. And the graph is all these points going to the right, all the way over to 7. So our domain is all points in the graph from -5 to 7. Those are all of the points from -5 to 7. And we got -5 to 7 right here. There you go. And we'll do one more here, guys. What is the range? Range, y values, range. And this is a finite set of points. When I say finite, meaning like there's a limited number, essentially. There's a limited number of points here. It's -7, -4, -1, 3, and 7. -7, -4, -1, 3, and 7. That's it right there. Boom. The key to this section is you got to understand the difference between discrete and continuous. You got to know what you're dealing with there and how that relates to domain and range. You obviously got to know domain is the input, the x values, range is the output, the y values. And then from there, it's just a matter of relating it to, do I have a finite set of points like these, or do I have an interval from here to here where it's all those points? The only way you're going to get better at this is just by practicing. So what I would say is do 7 problems in Khan Academy. If you get 7 out of 7, you understand the concept. If you get 2 or 3 or 4, do it again. You get 5, do it again. You get 6. Honestly, I'm a perfectionist. I'd say do it again. If you're happy with 6, you're happy with 6. It's your life. You make your own decisions. But I think you can get 7 out of 7 on this, and I think it's something that with a little bit of practice, it will be something that you couldn't easily master, and you'll be fantastic at this in our math class. All right, guys, you guys keep working hard. I will see you. I'm having issues with my thing here. I'll see you guys soon. Bye.